will present to you our next topic on case study, which is Experiment 6, High Liquid Performance Chromatography. Hi, so I will continue with the introduction. High Performance Liquid Chromatography HPLC is a chromatography technique that involves the migration of a mixture through a column that contains stationary phase and the mobile form is a liquid. The principle of HPLC is it primarily uses the column that contains the packing material, which is stationary phase, the pump that moves the mobile phases through the column, and the detector that displays the retention times of the molecules. The separations occur as the analytes and the mobile process are pumped into the column, and the detector reaction to each part is seen and known as a chromatogram. There are two types of HPLC, which are normal phase and reverse phase. However, reverse phase was used in this experiment as it can be used for polar, non-polar, ionizable and ionic samples. The instrument used in this experiment is HPLC ultraviolet detector and HPLC photodiode arrays detector.
For this experiment, the procedure we have two parts, which is part A and part B. So we will go for a part A. Part A we call it as experimental. Firstly, caffeine standard solution was prepared. The solution A, which is stock solution of 1.0 milligram per milliliter, was prepared. The 10 milligram caffeine was alkylate weight into a volumetric flask and was dissolved in the water. Next, solution B, which is working solution 0.1 milligram per milliliter, 1 ml of solution A was pipetted into 10 ml volumetric flask. After that, 10 ml of a soft drink, Coke, Pepsi, and 100 plus were poured into a small beaker. The magnetic stir was used to remove any carbonation. And then 2 anti 5 ml aliquot was filtered through a 0.45 micrometer diameter membrane filter to remove particulate matter. 10 micrometer solution B into the HLPC TP established the retention time of caffeine. The peak area of caffeine was measured. The 10 micrometer of prepared soft drink was injected into HLPC instrument. The peak area corresponding to the caffeine was measured by referring to their retention time. So next, we go for part B. Part B, we have two instruments, which is Perkin-Elmer series, HLPC UV detector, and HLPC PDA detector, which is Shimadzu VP series. So I will talk about the starting the instrument. For starting the instrument, we need to switch on. Do not switch on the PC first. So we need to push the on button according to the labeler hardware number. For the next step, we need to running the software. The method was created by click the class VP and the instrument 1. On the login window, the pump window was on and low pressure gradient was selected and was set up until 0.2 ml per minute. The pressure limit 2485 psi. Next, CTO 10 AS VP menu was clicked. Oven temperature 28 Celsius, Tmax 85 Celsius. Then SCL 10 AV was clicked to trigger type external and power on. Event 1. The status log menu and time program menu was clicked. At the time program menu, click download and they click on, then click apply. The LC setup where assistant icon was selected and PDA image was clicked. In the general menu, start wavelength 190 nanometer, 190 nanometer, and wavelength 800 nanometer. In library menu, do not change anything. In purity menu, from 100 nanometer to 800 nanometer. In data layout menu, channel 1 nanometer. In spectrum menu, do not change anything. In multi menu, insert appropriate data. In ratio menu, channel 1, click file method and save as the title of the experiment, or whatever name you want to put. LC setup assistant was clicked. The pump was turned on. The injection was proceed. Before injection taking place, click control, which is a simple run, sample ID, data file, click start. The syringe was filled with the sample. The maximum value in 20 ml and the sample quickly injected into the part. The result will show a chromatogram with several peaks. For the sample preparation, the shrink and filter was used to transfer sample into a vial. The mobile phase was prepared by filter mobile phase. For methanol water buffer and acetonitrile ACN, use membrane filter. The ultrasonic was used. The sample injection, click single run acquisition, insert shrink and lot. Inject sample, enter down. Next, select control and choose extend run. Select report view method, report. Lastly, the result was printed. So now we will go to the clean up process. Click LC setup assistant for mobile phase B, C and D. Wash with can, CAN. Click 100% CAN. Can for buffer, wash with water, click 100% water, switch off instrument. And we are done.
Assalamualaikum warahmatullahi wabarakatuh. I'm Hakim Rosman, gonna discuss about HLPC experiments. HLPC or High Performance Liquid Chromatography is the capability to isolate, recognize and quantify the compounds present for any samples. It is applied to any sample such as forensic samples, industrial chemicals and many other related samples. The basic components of HLPC is solvents, which is mobile phase, degassing system, pump, auto sampler or injector, column, which is the stationary phase, and waste, and also the detector. HLPC use degassing system technique. The separation is dim and isocratic relation if the composition of the mobile phase remains constant. The ratio of polar to non-polar compounds in the mobile phase is changed during the sample run. The gradient relation offers the most complete separation of the peaks without taking inordinate amount of time, which is the reverse phase gradient. Lowest retention time is chosen because of short and well-defined separation of time produce good results. HLPC mobile phase liquid, GC gas, HLPC column, glass tube, GC capillary tube. The response factor for caffeine standard is equal to peaks area concentration. For the concentration of caffeine, ppm in the unknown sample is calculated by peak area of caffeine in sample divided by RF. That's all. Thank you.
Hello, my name is Nurhanani binti Abdul Halim. I will continue for the conclusion of this experiment. The first one, the objective of the experiment is to determine the retention time of standard solution, that is caffeine. The second one is to identify the caffeine peak in a soft drink sample. The last one is to determine the amount of caffeine in soft drink sample using the response factor method. The advantages of high-performance liquid chromatography are it requires a small sample size, testing can be modified depending on level of quantification needed, and it also produces reliable results. And the limitation of high-performance liquid chromatography are no universal detector and less separation efficiency.